So this is a neural network that I've been working on to generate dual contouring, like surfaces, from a sign distance field without any Hermite data. And basically, what I do is I generate sign distance functions, like this. So these right here are just huge files with 1,000 sign distance functions in them, and you can see each one is about 1.6 gigabytes or 1.58 gigabytes right there. And I generate that data, but then I also generate the Hermite data that is corresponding to that distance field, and I use that Hermite data to train using the dual contouring error metric, so the QEF, instead of using the QEF to solve it during runtime. And so basically I can build a neural network that can learn the QEF without needing any Hermite data, and that's what this is doing right here. So you can see some pretty good, like contours that it preserves. These edges right here would not be possible with without using dual contouring before. But now with neural networks and only sign distance field information, I can create these really sharp edges pretty nicely. And like these cubes that are just rotated cubes they do a pretty good job of approximating. Of course, they're not perfect. You can see there's kind of like some broken edges here. But that's just sort of, there's only so much information that you can get out of sign distance functions. And yeah, so I can generate a different scene. Well, not generate, but I can load a different scene. You can see this is these pretty interesting results. Just these sharp edges that it creates, and as well as smooth edges. So smooth like toruses, but then sharp cube edges and stuff, and faces and all that. And I mean, there's still problems. I'm trying to think of solutions to solve these problems, but right now I'm pretty happy with these results. It's just a convolutional neural network with some skip connections and things like that to get these results, and it's a pretty small network overall. Doesn't use too much. It doesn't use too much like memory, and it runs pretty quickly. You can see if I unpause the training down there. See right here, this is where it's training, and if I unpause that, you can see how quickly it updates. And this is actually running at the frame rate of this thing, and each time it's running, it's generating four files. So you can see right here, if I pause this, you can see it's going from 92 to 96, so that's 4 things, and it's generating in less than, like, in a split second. And so yeah, my hunch is that it's going to be faster in, like, this is pretty nice, look at this edge. My hunch is that it's going to be faster in C++ when I actually apply it to the to a more production ready thing. I'm planning on moving this thing to a C++ backend with Tensorflow just for inference of this model. But yeah, so these are pretty nice results. Look at that. Look at that thing. But yeah, it just uses the QEF as the error metric, and it doesn't use it during construction, only using sign distance functions. Tried out different models. The first model I tried out was at about 340, 300 loss of 340, and this one's at about 230, 240 range. It fluctuates between 230, 240 loss, and so I've refined a lot of the functions. But I'm going to try out different neural network functions, see what I can do to improve. But so far, I'm pretty happy with these results. Yeah, look at that cube just sticking out of the torus. Yeah. So I'll just show you a few more here. So yeah, it does have some problems here, like this thing right there. That's mostly just because of the fact that it's it's still just a sign distance function. It's still using a dual method, and so it has to generate a vertex there, even though they don't necessarily connect, because they're not. It doesn't have that kind of information. This is a little cute. So you can see, like this right there is a pretty bad edge. But overall, I mean, it's doing a pretty good job of all things considered. It's better than the average or a surface nets approach, which is what you can do a surface nets approach if you don't have any Hermite data. And I was planning to do this for a function that doesn't have any Hermite data, and I'd prefer it to work well. But yeah. So yeah, that's about it. I'll be updating you guys on any sort of future progress. I'm kind of excited for this thing in the future. It's a fairly difficult little challenge here. But I've always wanted to be able to do this without any Hermite data, because I've hated the constraint of being required to use Hermite data, but this seems to be doing a good job. Look at these little cubes all stuck in here. Kind of excited to see because in the early stages of development, the neural network was just doing whatever it wanted, and so it was like this really curvy, random shapes that it was creating before it was trained. And that was kind of interesting to see. Kind of gives you an insight into what the function of the neural network looks like. Anyway, point is, progress is coming along, and I'll talk to you guys later when I have any new updates on different architectures and things like that. If you guys have any questions, like if you guys want to try to implement this on your own, or learn how to implement it or something like that, I might make another video for that, like showing you what I did, what the neural network is. I mean, you can see it kind of right here, if you want to just pause while I'm going through this, but this is pretty much the neural network, everything right here. It's just a 32, 32, 32, 32, 32 convolutional neural network, and then I add a skip connection from all of these to here. So with this concat, I just concat the result of all these things, and then I convolve it with the padding of valid, and then a kernel size of 2, and so that basically combines the edges, and then I go again 32, 32, 32, 32, all the way down until I get a 3x3 vertex function, like vertex field. So it has just 3 kernels and a kernel size of 3, and it it concats all of the previous results of these. So from right here, and that way it's like a skip connection to all these, and then this one's a skip connection to all these. And then right here, this is my custom loss function. It's kind of complicated, but if you want any explanations, I can do that. Anyway, point is, see you guys next time, and hopefully I can make some improvements and see what happens. Ooh, look at this, actually. Look at that. Wow. That is a nice cut. Look at that. You could not do that with surface nets. Anyway.